You know I'm gonna get you, yeah. Whatever it takes to get there. No, I won't drop you like everybody.
A train moving at a speed of 40 meters per second sound its whistle, which has a frequency of 5.00 times 10 raised to the power of 2. Determine the frequency heard by the stationary observer as the train approaches the observer. The ambient temperature is 24 degrees Celsius. Given the speed of the source, 40 meters per second, frequency produced by the source, 5.00 times 10 raised to the power of 2 Hz. Speed of the observer, 0 meters per second, since the observer is not in motion, at a temperature of 24 degrees Celsius. Problem is to determine the frequency heard by the observer. We are going to use the Doppler effect of sound equation. Frequency detected by the observer or the listener is equal to the speed of sound plus minus the speed of observer plus if the observer is moving towards divided by the speed of the sound plus minus the speed of the source plus if the source is moving away. Since the given is only the temperature, we are going to use it to determine the speed of the sound at 24 degrees Celsius. 331 is the speed of sound at 0 degrees Celsius. Substitute the given temperature, which is 24 degrees Celsius, and cancel the Celsius unit. 0.6 multiplied by 24 is equal to 14.4. 331 meters per second plus 14.4 meters per second is equal to 345.4 meters per second. We have now the speed of the sound at 24 degrees Celsius. Substitute all the given value. Given the frequency of the source, 5.00 times 10 raised to the power of 2 Hz, and the speed of the sound at 24 degrees Celsius is equal to 343.4 meters per second, plus the speed of the observer, 0 meters per second, since it's not moving, divided by the speed of sound at 24 degrees Celsius is equal to 343.4 meters per second, minus 40 meters per second, since the source is moving towards the observer. 345.4 minus 40 is equal to 305.4. 345.4 divided by 305.4 is equal to 1.13. 5.00 times 10 raised to the power of 2 Hz multiplied by 1.13 is equal to 565.49 Hz is the frequency heard by the stationary observer. Determine the frequency heard by the stationary observer past the train recedes from the observer. We are going to use the previous problem and given of the speed of the source, 40 meters per second, frequency produced by the source, 5.00 times 10 raised to the power of 2 Hz. Speed of the observer, 0 meters per second, is still not in motion. Speed of the sound, 345.4 meters per second. And the problem is to determine the frequency heard by the stationary observer past the train recedes from the observer. Again, we're going to use the equation Doppler effects of sound. Substitute the given frequency produced by the source, 5.00 times 10 raised to the power of 2 Hz, and the speed of sound, 345.4 meters per second, plus the speed of observer, 0 meters per second, and the speed of the sound, plus 40 meters per second, since the source is moving away. 345.4 meters per second plus 40 meters per second is equal to 385.4 meters per second. 5.00 times 10 raised to the power of 2 Hz multiplied by 385.4 meters per second is equal to 448.11 Hz. 448.11 Hz is the frequency heard by the stationary observer past the train recedes from the observer. In problem number 1 and 2, it implies the Doppler effects of sound, which the frequency of sound decreases as the source of the sound recedes from the observer, and the frequency increases when the source of the sound is moving towards the stationary observer.
you